This is NFC Security Systems by Zachary Campbell and Kieran Minardi.
So our original objectives were to implement an NFC controlled electric door lock with the use of the Arduino Duo. So the idea was we'd provide access to individuals with the correct swipe card, as with most security door systems and things like that. And then with the other side of it, we'd also reject them. So if they were rejected, we would actually send an email, or similar to a dummy security company, or someone of security power in the company, so that they can kind of keep track of these. Original kind of idea was to log and chart the statistics of who'd come in, accepted or denied, what times, things like that, and hopefully get some graphs and stuff. Unfortunately, with time and some complexities, they we had a few issues with that, and unfortunately we're not able to implement it.
The design of our embedded system can actually be broken down into several different building blocks. We have the Arduino Duo, the NFC shield, the electric door strike circuit, and also the email alert system. The NFC shield we actually used MyFair Classic and MyFair Ultralight cards. The standardized library we used was actually developed by NXP, and it is the standardized library for the NFC readers. The NFC shield also has a 4-inch read range for these NFC tags. The electric door strike circuit we used was rated with 12-volt DC at 200 milliamps, and this was powered from our Arduino using a relay to control this external circuit. We only had the choice of a FSS-1 102Z rated at relay at 5 volts in 2 amps. We also added in a parallel buzzing switch, which is actually a manual override. So this can act as someone who's actually past this door point. They can actually buzz you in if you don't have a card or anything like that.
With software design, originally we were hoping to kind of get a web page that had dynamic links to a few things and a Gmail client server. Unfortunately, there were a few issues with the Ethernet and connections with Gmail. They had multiple dynamic IP addresses and a subnet and a few gateways. Also with the HTTPS encoding and the recent Heartbleed bug, it's a bit harder to get on. So we implemented a Twitter server instead. Just used zero auth, which is quite easy to get a token for. You just add it into our libraries. There was a Twitter library already for Arduino that was built to deal with this. And to get the email, I used the Twitter API to just kind of implement an email based alert system.
To test our entire embedded system, we decided to actually break all the components into their own little building blocks. The first being the electromagnetic lock circuit. We connected the electromagnetic lock with a switch and combined that and joined that to our 12-volt DC 200 milliamp power source. We then noted that when the switch was depressed, the door actually unlocked. Later on down the track, we implemented a Arduino controlled relay.
So for the RGB LED, it was less of a hardware issue and more of a software. So we just wanted to test some libraries that created some abstraction with some arrays, so that we could easily, at the end, just do set the LEDs to a certain color, so it was easily readable and accessible at points through the code. So the NFC shield was a bit of an issue. We had a couple of issues with it. First off, it just wasn't reading anything when we started it. So we applied the code of our own design as we had built from before. It didn't work as usual with most things on the first time. So we applied the NXP manufacturer's NFC library. Adafruit also had some example PN532 libraries. We were using the MyFair Ultralights. We found these to be verified by the NXP app on an Arduino phone, actually several Arduino phones. The code basically wasn't picking up anything. The antenna wasn't picking up any of the chips. We noted that from the previous app that there was information on them, but nothing had come through. So we changed the shield input, hoping that maybe that was it, because we'd seen that I2C was meant to be used for shields. We changed it. Unfortunately, it wasn't picking up the firmware of the board, and so SPI was the obvious choice. It also directly connected with the shields. We then thought, well, maybe since the tags are fine and the shield connection is fine, maybe it's actually the antenna. So we actually did continuity testing of the antenna cable. Found out that this was completely fine. We then did some multimetering of the board, but it was too complex to really understand, and the time to do it. Basically, just sent a dud board. Here we go. We'll add in, show you the acceptable codes. There are 55 and 66 at the moment. So let's say 55 in our database. Boom, light turns on and door opens. The light will stay on until the door closes for 2 seconds. 1, 2, or thereabouts. Here you go. Show it where the door doesn't ever open. 55 again. Lights on. Time down, and boom, lights are off. Last thing with this, we'll show invalid number. So we get a denied. No, because I typed in the wrong number. I typed in a special number. I accidentally typed in. No. Denied is red, and the door is locked. Ding, ding, ding. Also in denied, it will send a tweet. At the moment we don't have the Ethernet connected, but these are previous tweets. Exactly as, and then after that, through a web server, it will send to designated emails, the time of occurrence, and the message in the tweet.